So students always need lots of practice solving NMR spectra and structures. So here we have C3H6Br2, and you're told this is a difficulty level of 1. That's to humiliate you. I'm sorry, no, I don't know why they say that. We have some 2s coming up and maybe a 3 somewhere. Now on lots of quizzes and exams, you don't have this thing. You just have this information here. I went and found this thing. Now what's the first thing I do when I see a molecular formula? I go CN2 plus 2, and I go 2 times 3 is 6 plus 2 more is 8. Well, I got 6 hydrogens and 2 halogens, so I get to my 8. So there's no degrees of unsaturation. And then you look at this and you say to yourself, how many different types of protons do I have? Now I'm going to just blindly do something maybe not very logical. What would the NMR signal for this look like? That'd be, yeah, 1 singlet. So that tells me that's not the structure. Perhaps we can be a little more intentional about what we're doing. But one way would be draw every isomer. Now what do it says here we have a quintet. What does that mean? 5 times, right. And here I have a triplet. So what does N equal for a quintet? 4. And over here for a triplet, this has got to be equal to 2. So I'm going to just say, now granted, how can I get 4? I think the problem just did itself. So I'm going to label these A. These are in the same chemical environment. They're going to give rise to a signal. This one here is in the same chemical environment. It's going to give rise to a signal. I'm not sure I like this. No, I like it. A is the furthest down, most de-shielded. These are the most shielded, and that's the triplet. What do you think? So a lot of these, maybe it's why students have difficult times, and maybe that's why it's a beautiful thing intellectually, like a lot of chemistry is. You don't know the answer till you try and solve it. And a lot of people don't like that uncomfortable feeling of looking at something and having no idea, but as you work along, it should become more obvious. Really wish I would have printed out a paper copy and used the camera. Deduce the identity of the following compound from the proton NMR data given. I hate looking at that crack. So what's the first thing I do when I see a formula of a compound? Yeah, I go 8 times 2 is 16 plus 2 more is 18. I got 10. Oxygen doesn't supposed to change anything. Oh man. All right. 2 times 8 is 16 plus 2 more is 18. 8 divided by 2, 4 degrees of unsaturation. So I gave you a shift table, and I also mentioned this in the lecture with the slides. Whenever I see some mess around 7, what do I think? Well, let's look at this. Approximate 7.2. I'm looking at a little different shift table than the one I gave you. Let me see if I can find the one I gave you. An aromatic ring, absolutely. 5 hydrogens, apparent singlet. And I said, well, I see some bumps. It's not really a singlet. Sometimes I just tell students, anytime I see a group of peaks, There's probably a benzene ring going on. All right, so that gives me 6 hydrogens. It says I have 10 hydrogens. All right, well, how many carbons did I burn up? 1, 2, 3, 4, 6. So I have 2 more carbons I got to work with. All right, so now let's go to, and here is the integration. So I have 3 hydrogens and I'm getting a singlet. A methyl group, if it's stuck to something that doesn't have any hydrogens on it, it can give us a singlet. I have 2 hydrogens here giving me a singlet. All right, let's see where we're at. I'm going to erase a hydrogen. Now I have 1, 2, 3, 4, 5. 5. We're getting somewhere. Here's 3 with a singlet. Here's 2. Let me sum up all my hydrogens. Here's 2, 5, 6, 7, 8, 9, 10. Now I just need to put in an oxygen. Just to play an advocate, do I want this type of oxygen or this type? Well, let's go back to the very first thing I do is I look at the degrees of unsaturation. We have 4, and we have a benzene ring, and so I can count my degrees of unsaturation. I have double bond, double bond, double bond, and then a ring. So I got my 4 degrees of unsaturation, so that means I might as well use an oxygen that doesn't have any double bonds. So now the question is, how do I want to connect these? Got to connect them all up to the ring. Well, let me try this way first. Would that be reasonable? Let's count signals. 1, 2, 3. 1, 2, 3. All right. Now I saw one of you shaking your head. Triplet, quartet, singlet. I don't see that. I see singlet and singlet. We wanted this thing by itself, and we needed the C2 by itself. Now how's that looking at us? So this would give us a singlet, because there's 1 bond, 2 bonds, 3 bonds. These hydrogens are 4 bonds away from those hydrogens. Those aren't going to split each other. Let me count here. I imagine a hydrogen down there, and I go 1, 2, 3, 4 bonds away. So now I think this is all working out, and this is indeed the structure. Benzyl methyl ether. Once again, difficulty of 1 to demoralize you when it's harder than anything you've ever seen in your life. So now, of course, you're ready to do difficulty number 2. Deduce the identity of the following compound from the proton NMR data given. Here's the molecular formula. At a delta value of 4.5, we have a triplet that integrates to 1 hydrogen. At a delta value of 6.1, we have a doublet that integrates to 2 hydrogens. What are we going to write for a structure? C3, 8, 3 of those, 5 of those. It's unsaturated. There's no double bonds. Granted, a little hard to have a ring. So maybe this will be our plan. A triplet, that means there's 2 hydrogens close by. A doublet means there's 1 hydrogen close by. Well, man, there I just burned up all my hydrogens. Well, for lack of anything better to do, let's just hook that up. What's going on? I need another carbon. Fill in everything else with, could that be it? 1, 2, 3, 4, 5, 6. So, that's not it, man. What is this, Eric? I put 5 bonds on a carbon. I need to be fired. 1, 2, 3, 4, 5. Oh, man. Well, we're slowly going to get to where we need to be. This is difficulty 2, remember. 1, 2, 3, 4, 5, 6. Oh, I don't have all the hydrogen I used to have anymore. So I got to erase a chlorine. See if I get my chemical formula. 1, 2, 3 carbons. 1, 2, 3 hydrogens. All right, so far so good. 1, 2, 3, 4, 5. Now, I think there could be, so far this is looking good in that, what's this going to give me? A triplet. I got 1 hydrogen giving me a triplet. I got 2 hydrogen, what's this going to give me? Split by that's going to give me a doublet. Now, I foresee one problem, but now that we're kind of got the general gist of what's got to happen, I'm thinking I got to have, so instead of having 2 hydrogens here, let me put my 2 hydrogens there and 1 hydrogen there. So there's the chlorine that was there, and I'm going to add 1 more chlorine. Let me name this. 1, 2, 3, 4. Let me fix that. I need penta, 5 chlorines. Or 1, 1, 1, 2, 3, pentachloro. Natives are getting restless. I can hear the rustling. I think both of these work, but one's going to work better than the other. And how are we going to figure it out?
The amount of dealing.
Right. Let's think about where these peaks show up. This one down here, it's got to be the most deshielded, least deshielded. Oh, and I did it again. So this one has, I'm going to just draw what I'm seeing. Doublet, triplet, doublet, triplet. I think that's working with this one. Where this one here, this proton is on a carbon with 2 chlorines. These hydrogens are on a carbon with no chlorines. So I'm thinking this thing's going to have the triplet here. I think that corresponds to that one. And then, of course, this says my doublet is the furthest up. I think I have the answer. And I stand corrected. There is a third option. Maybe this should have been a 3. I'm up here thinking, man, this 2 is so simple. Symmetry. Symmetry. Symmetry in old age. I looked at this when I was putting it together. I should have remembered, huh? This is the correct answer here. So this proton here is going to show up as a triplet. These 2 show up as a doublet. And these are more deshielded. They're going to be further downfilled. Now, on any quiz, I would give you credit for either of these 2 structures. Maybe we need some carbon NMR. I bet you that would fix this problem. That'll be tomorrow's lecture, carbon NMR. Tune in. You'll want to watch it or be here live.